This is pre-calculus, notes on section 5.1. The name of the section is Radicals and Rational Exponents. And the name of this video is Definitions. Okay, so make sure that you get all of this page in your notes. What does this say in plain language? That, first of all, the nth root is the same as taking whatever's inside that radical and raising it to the power of the reciprocal of the index. So the nth root of c is equal to c to the power of 1 over n. Underneath that is some descriptions about what do you do with the signs, okay? So if we're taking an odd root, okay, there's only one answer. If the stuff underneath the radical is positive, the answer is positive. If the stuff underneath the radical is negative, the answer is negative, okay? If you're taking an even root, okay, you can't take the even root of a negative number. So first of all, we're saying only if the radicand is positive, and then if you're taking the even root of a positive number, we would say that there were two solutions, both positive and negative. So in order to make this a function, we're going to say, well, we're only going to take the non-negative solution. So we only have one answer. All right, moving on. Make sure you have all that in your notes. All right, here are some examples of everything that I just said, and the examples are all worked out for you, okay? Our first problem, okay? Here I've got an odd root, right? Since the radicand is positive, the answer is positive. Okay, positive 2. Here I've got an odd root. Okay, since the radicand is negative, the answer is negative. All right, here I've got an even root. Okay, so for even roots, you could have a positive or a negative, okay? But what we're saying is that we're only going to accept the positive answer. And last example, here we've got an even root of a negative, and there is no defined answer, so this does not exist. We don't take the even roots of negative. Okay, so if you'd like, you can give a try to these. Pause the video, try them yourself. I'll have my solutions in a few seconds. Okay, problem number 1 is positive 4. It's an odd root. The radicand is positive. The answer is positive. Problem number 2 is negative 3. Okay, it's an odd root. The radicand is negative. The answer is negative. Okay, 16 to the 1/4 is equal to the 4th root of 16. Okay, so the number that I can multiply by itself 4 times that makes 16 is 2. 2 times 2 times 2 times 2 is 16. It's an even root. Okay, so that means I'm just going to take the positive answer. All right, next page. All right, now here I've got both a numerator and a denominator in the exponent, all right? So, okay, here's what I want you to know. The numerator, okay, of that exponent is going to be the power, and the denominator of that exponent is going to be the root, Okay, so here we've got the example. Okay, so we're taking the third root, because 3 is the denominator, of 8, and then raising it to the power of 2. Now, if you wanted to, the order's not important, okay, you could take the 8 to the power of 2 first, and then take the cubic root. So order is not important, okay? Or in other words, both roots and radicals have the same order of operations, okay? So it doesn't really matter what order you do them in. All right, here we've got some problems for you to try. Oops, sorry. You might want to pause the video. I'll wait a few seconds and I'll display my answers. All right, here I've got the square root of 3 to the 4th. 3 to the 4th is 81. Okay, since it's a negative being raised to an even exponent, the answer is positive. And then I take the square root of 81 is 9. All right, problem number 5. I'm looking for the third root of 27 raised to the power of 4. The third root of 27 is 3. 3 to the power of 4 is 81. Okay. Problem number 6. I am looking for the third root of negative 64 raised to the power of 2. Right, the third root of the negative 64 is negative 4. Negative 4 to the power of 2 is positive 16. All right, that's it for that video.